This is lesson 32A in algebra 2, quotient theorem for square roots, congruency, and congruent triangles. Alright, so remember from past lessons when you have something like this, square root of 3 times 2, that equals the square root of 3, square root of 2, which also equals the square root of 6. Alright, the same rule applies when you're talking about square roots, when you're talking fractions or division. When we have that, that is equal to the square root of 3 over the square root of 2. Problem is you can't have a radical in the denominator, so what you do is you multiply the top and bottom by that square root, and now we multiply what's on top, square root of 6 over square root of 4, which is 2. So basically the radical sign comes off and we're left with the square root of 6 over 2. Same thing happens when we have square root of 3 over 7. That equals the square root of 3 over the square root of 7. And then we multiply top and bottom by the radical that's on the bottom. And we get square root of 21 over 7. Okay, let's look and see what happens when we have like example number 2 there. We have the square root of 2 over 5, and we also have the square root of 5 over 2. So the square root of 2 over 5 plus the square root of 5 over 2 equals square root of 2 over the square root of 5 plus the square root of 5 over the square root of 2. Alright, common denominators. Well, it's kind of a pain when you have the radicals on the bottom, so what we do is, again, we multiply the top and bottom by the radical that we're trying to get rid of, and that gets rid of our radical on the bottom. Okay, looks a little bit easier because all we have is that radical on, or the numbers on the bottom. And now we go back to the typical, I've got a 5 here and a 2 here. What do I have here that I don't have here? A 2. So I multiply the top and bottom by that 2. And then I look over here. I have a 2 here, but what am I missing? This one has a 5. So I multiply the top and the bottom by 5. And that gives me 2 square root of 10 over 10 plus 5 square root of 10 over 10. And now I can add these together. 2 square root of 10 plus 5 square root of 10. And because the numbers under the radical are the same, that means I can add this number to this number and get 7. The radical, everything in there, when you add the radicals, nothing changes. Okay, it's kind of like 2x plus 3x equals 5x. It does not equal 5x squared. When you multiply them, it changes. But when you add these, you don't do anything with the variable, just like you don't do anything with what's under the radical sign. You just add the numbers outside there, and that is over 10, and you're done. Okay, this is example number 3, and we're asked to simplify that. So first of all, what we're going to do is we're going to rewrite the radical signs so that they're under their own radical. Then I'm going to multiply top and bottom by the radical. This is called rationalizing the denominator. And I get 3 square root of 21. See, I can multiply those. 3 times 7 is 21. You can't add them, though, because they have different numbers under there. So 5 square root of 21 over 3. So I have different denominators. So again, what do I have here that I don't have over here? I have a 3 here and a 7 here. So I'm going to multiply this by 3. And I'm going to multiply this one by 7. So that gives me 9 square root of 21 over 21 minus 35 square root of 21 over 21. Now I can combine these, and I can combine them. for two reasons. I have common denominators and the number under the radical is the same. Those two things have to be true or I can't combine. So 9 minus 35 is negative 26, square root of 21 over 21. And I'm done. Alright, let's do one more. And we'll call this section of the lesson done. So we've got 2 square root of 2 over 7 minus 5 square root of 7 over 2. Okay, I'm going to write it as square root of 2 over square root of 7 minus 5 square root of 7 over square root of 2. So, rationalize the denominators. So I have 2 square root of 14 over 7 minus 5 square root of 14 over 4. I need to find common denominators. Oops, I'm sorry, that's not a 4, is it? It's a 2. Square root of 2 times square root of 2 is square root of 4, which is 2. Alright, so I multiply top and bottom over here by 2, top and bottom over here by 7, and I get 4 square root of 14 over 14 minus 35 square root of 14 over 14. And because, again, my radicals are the same and my denominators are the same, I can go ahead and get negative 31 square root of 14 all over 14 and call it good. Okay, so that's it for the first video for 32A, and we'll continue on with this lesson in 32B.